Hi everyone, and welcome back again to my channel. Today we're going to look at something unique. Someone had made a request to us to show a little bit more how to read and understand electronic circuits. So that's what we're going to be doing today. It might be brief, it might be long, depends on what we get, but we're streaming live right now. So let's just get into it. All right. All right. So this is my channel, and I'm going to go quickly to the page that we're going to be reviewing today. In the days, I had a group of friends and we had embarked on designing some circuits from this book called Encyclopedia of Electronic Circuits. We had looked at this circuit diagram. This is an inverter. And if you want to analyze the circuit, you will see on the left-hand side here, you have an unstable multivibrator, and then you have power amplifier transistors driving a transformer. So basically, the frequency is determined by the left side of the circuit, the unstable multivibrator, and the power transistors 2N3055 drives a step-up that goes to your load. So we went on and built this circuit, and it didn't work. We built it exactly as it is. Probably maybe if we are off in the capacitors or something, maybe we chose particular capacitors to give us some frequencies, but doesn't matter what we did on that day, this circuit did not work. And all of a sudden I said to my friends, I said, this circuit is wrong. I was wrong. And they looked at me and wondered why I would say that. This is, after all, an encyclopedia of electronic circuits, so it must be right. So how did I know it was wrong? Okay, I'm gonna get to that. There was another day I went to the electronics market in my state to buy some components to build something, and I had met a guy at the store, and he had the circuit diagram in hand, and he was trying to buy the component for it. So I asked him to let me take a peek at the circuit diagram. So he did let me take a peek at it. When I looked at it, I said, there's something wrong with the circuit. And he was shocked as well. He said, why do you say that? And then I showed him something that I'm going to show you right now. And I helped him fix that circuit. So back to the original story, this Encyclopedia of Electronic Circuit inverter. I told my friends it was wrong, and we made small change, just a very little change, and the inverter was working. I think that was our second year at the university. So let's just go right into it, and I'll show you what I mean by that. All right. Um, okay, let's see if this can help us right there. I have to get to a different view. All right, so this is the one we're looking for. This one right here is what we are looking for. If you followed us from the beginning, we had talked about transistor biasing. So if you haven't looked at our basic electronic circuit, please go and look at basic components. I'm going to put a link to the video after the fact. So since I'm streaming live, I won't be able to do it right now, but I will go back and edit this video and I will put a link to that basic electronics tutorial, basic components. What we said was that there are two basic transistors, the NPN and the PNP transistor. If you look at this circuit here, we have two PNP transistors and two NPN transistors. Basically, when the arrow is pointing outwards, it's NPN. When the arrow is pointing inwards, it is PNP. Another way is you can just look up the transistor numbers and look at the pinouts and read a little bit about the transistors, and you can tell. But what I've shown you is that if you two transistors, let's take Q3 and Q1, and you have the arrows on the same side as they are right now, and you put a stroke by the left side of the arrow. If it looks like an N, then you have an NPN transistor. So in this case, if I could draw an N around here, then if I can put an arrow, you will see it will look like an N. Likewise, on this side, if I put a strike here, it won't, because they're facing on the same, and I have to put it on the left hand side. I'll be putting it on this side, not on the up side, not on the down side. When I put the stroke, it won't be an N, it will be an inverted N. So because this, so remember, the two arrows has to be on the downside, and you have to put your arrow only on the left side, right? You can change it, because if you put the arrow on the right side here, it will be wrong. It will show you it's not an N, but you need to put it on the left hand side. You have to remember this. So for an NPN transistor, let's go back to that image because it helps to understand this. For an NPN transistor, the emitter of that transistor is the most negative. So the three dashes represent more negative. So a dash represents negative. So the emitter, so just write NPN, and underneath you write EBC, emitter base collector. In the other video I had talked about this, saying the polarity that is seen is the odd one out. So P is the odd one out in NPN. So the odd one is the base. For PNP transistors, the N is the odd one out, so the odd one is the base, always. So for NPN transistors, the emitter is the most negative. The base is less negative than the emitter and less positive than the collector. And the collector is the most positive or the most negative, if you will. The most positive or the least negative, sorry. The collector is the most positive or the least negative. Now let's look at the PNP transistor here. The emitter should be the most positive, the base less positive than the emitter, and more negative than the collector, and the collector is the least positive or the most negative, if you will. So let's go back to that Encyclopedia of Electronic Circuits and look at it. This NPN transistor, we've established that for an NPN transistor, the emitter is the most negative. When we look at this circuit here, the emitter goes to ground. We might think, oh yeah, it's negative, right? It goes to ground. That's what it should be. How about the power supply to this circuit? The power supply shows us, from what we know, from what we looked at right now, we're expecting the emitter to be the most negative. But is that what we're seeing? The emitter actually connects to the positive. You can see plus 12 volts. So it fails this test right away. The emitter is not the most negative. The emitter is the most positive. For the PNP transistor, the emitter should be the most positive. Did it pass or fail the test? We're looking at most positive for the PNP. So this PNP transistor, looking for most positive, no, it is the most negative. Or the more negative, because you have just two terminals here, but you get the point. So what we did with a lot of caution and with my among my friends, we were able to change the polarity, and this inverter worked as planned. This is an Encyclopedia of Electronic Circuit. We had borrowed this book from the library in those days, but I found a circuit, the exact encyclopedia online, so you can look at this circuit yourself. Now, it could be just a typo, but there are other circuits where you can have this kind of error. So, my friend, I'm doing this video specifically for you because you requested to know how to read electronic circuits. And I'm going to say this, there's no shortcuts to this. You have to learn the basics. So Good for you, we had created a video, a tutorial on all the basic components. Well, not all, but most of the basic components. So we have talked about resistors, capacitors, transistors, transformers. Everything here we've talked about. Everything in this circuit we've talked about. So you build your repertoire, you build your electronics vocabulary, if you will. I will encourage you to also know all the electronic symbols, because these are the basic building blocks. If you want to be able to read electronic circuit, you should be able to know the basic building blocks. At least know the basic components. And then with time, as you keep coming, you keep building your confidence, building your knowledge base, and you should be able to read electronic circuits so easily. I'm going to tell you one more thing about transistors. When you have a transistor, a 3-terminal transistor, and you want to check the emitter, base, and collector, as you put your probes on the 3 terminals, so you're going to take 2 at a time, at one point, you're going to get a deflection. And then by the end of the day, you find out that with one terminal, one probe on one terminal, you can get deflection on the other 2 terminals, or the pinouts. The common of those pins is the base. The other 2, one will be the emitter and one will be the collector. The question will be, how do you tell the collector from the emitter? Because you can easily tell the base. If you put a probe here, and if you put a probe here and you try to read, so let's say you put a probe at the base of this transistor and you try to is, how do I tell the difference? I can tell base because it will read with the collector, it will read with the emitter. But how do I tell the collector from the emitter? I'll give you a simple trick, okay? And the trick is, once you identify your base, when you're trying to identify your base, you just want to see a deflection, okay? Once you get the deflection, the reading on your meter, or either analog or digital meter, when you see a reading for the 2 terminals against the base, you're sure, you know the base. To find your collector and your emitter, you have to pay attention to the values. Again, pay attention to the values, the resistance values. So you're going to set the diode range on your multimeter, either digital or analog. Set your meter to the diode range, and you look for the actual values. The emitter is ever so slightly higher than the collector reading. So let's say you use a 2N2222, for instance. The base to emitter reading for that transistor will be around, let's say, 617. But the base to collector reading will be around 615 or less. The emitter reading will always be slightly higher than the collector reading. So you put that in your pocket, and you keep coming. We're gonna be making more videos depending on your requirements. Today we're taking a break from node MCUs and ESP8266, ESP32s, and so on and so forth. And we decided to make this. So next week we're going to look at a different video. We're going to do 555 timer with the traditional 555 timer. So we're going to build a LED blinker, easy one for you. But then we're going to look at it using we're going to look at LED blinkers using Arduinos. And it should be an easy one too. But what we're going to do more is to transfer that code, which we're going to use for that LED blinker, into an ATtiny 13A. And we can show you how easily you can take your analog electronics into a digital electronics, and you can change the pulse width, the duty cycle, just by changing few codes. All right, and this will be very helpful because you're going from a hardwired system to a software system where you can easily change the setup, change the cycle, change the pulse width, and you can change the function according to the day. or according to events. Let's put it that way. You can change the function by certain events, and you can make it perform multiple functions depending on events, versus the hardwired world where once you build it and you solder it, you are done. So that's what we're going to be looking at for next week. But today, we just want to help a friend who had subscribed to our channel and has made this request. Again, I'm going to ask you to please subscribe, keep coming back to this channel. You can make a video request and we'll try to meet it as much as we can. Yeah, so this is my digital meter, one of my digital meters, and I have a filter on the background, so it's affecting the colors here. But let's see. So if you want to use this to read your transistors, you want to be looking at the diode range. Okay, can you see that? The diode range. That's what you select when you want to read the transistor. You can also, if you have this other type of meter, if you have this type of meter, you can use the HFE range, right? You can use that, plug in your transistor, and you get the HFE reading. If you know the HFE reading of the current, so voltage, resistance, and current meter, whereas the other meter is your resistance, inductance, capacitance meter, all right? Resistance, inductance, capacitance meter. All right, so you might need something like this. You can use an analog meter, and it should work well. You just have to know how to use it and select the right ranges, and you'll be good to go. All right, I want to thank you for coming out again, and please subscribe to this channel, keep coming back, share with your friends, and don't forget to give us your video ideas in the comment section, and we'll be able to help. At the end of the day, I like seeing people successful, people happy, and people enjoying what they are doing. I've been doing this for years and years and years when I was a little boy, and it's just one of my passions in life to see people succeed and to see people happy about what they're doing. I've built a lot of lots of circuits for people, and I've taught a lot of people as well. Now, after next week, remember I said next week we're going to be doing 5-5 timer. Let's change the name. Let's say LED blinker with 5-5 timer versus LED blinkers with Arduinos or microcontrollers. Then after that, maybe the week after, I have to check our schedules, but maybe the week after, we'll be looking at amplifiers, right? We'll be looking at amplifiers. So we're gonna build an amplifier, build a mixer, build a tone circuit, and we might not build all on the show, so we probably show them built, or we'll just describe the circuit diagram. We can build them in stages. Maybe I think it's better we'll do them in stages so it's not too long. All right, I'll see you next week and the week after and the week after that, God willing. All right, thanks my friends. Stay safe. All right, stay safe. Yeah, the world we are in now is an interesting time, so stay safe. All right, whatever you do, stay safe and stay hungry and keep coming back. Please subscribe. I can't say this enough. Please, please, please subscribe. All right, thanks, and bye bye.